Okay, this is lesson 12-8 and 9, surface area of prisms and cylinders. Okay, so now we're going to start looking at surface area. So we're going to have two things that help us find the surface area of a 3D shape. We're going to have what's called lateral area. Okay, and it's sum, your lateral faces. The surface area is the sum of the lateral area plus the area of the bases. Okay, that sounds like a bunch of mumbo jumbo, but these pictures help. So, if you notice, when you take like a figure apart and lay it out flat, that's called its net. Okay, and if you notice, this has exactly two bases, the top and the bottom, and the rest are faces. Then this one also, top and bottom that are triangle, and the rest are your faces that are rectangles. That's what prisms are named by, the base that's exact opposite one other base. Okay, so we're finding the area of it laid out flat. That's what surface area is, just what touches around the outer edge of something. For example, like a Christmas present. If you wrap it, that is the surface area. So let's look at the formula. So capital L means lateral area. Okay, it's the perimeter of the base times the height of the prism. So capital P means perimeter of the base. Perimeter just means you add up all four edges. So L equals capital PH. So then to find the surface area, it's your L, which we just talked about here, plus 2 times big B. Big B means the area of the base. So you could, if you wanted that L equals PH, you could just say, okay, well, surface area equals that, capital PH, plus 2 big B. So I would for sure write both of those down. Lateral area is capital PH. Surface area is capital L plus 2 big B. So let's look at an example now. Okay, so we'll look at a triangular prism and a rectangular prism. So it says find the lateral and surface area of each prism. So on A, we first find the lateral area. L equals big P, H, capital PH. Perimeter of the base. Okay, so on this one, the base is this at the bottom. One side is 5.5, which means this back side's 5.5. So they said, okay, 2 times 5.5, because there's 2 of them, plus 2 sides that are 3. So plus 2 times 3. That is just finding the distance around this bottom. It's 3 plus 3 plus 5.5 plus 5.5. That's what they've done here in red. Then we have times the height of the whole figure. So this number that we found is just the lateral area. So that's one answer. Now, the reason it's helpful to go ahead and do that is to find the surface area. If you notice this capital L, that's the answer we just found. So the surface area is L plus 2 big B. So we already have our L. It's this previous number. Plus, big B means the area of the base. So this figure is a rectangular prism. So the area of a rectangle is length times width. So it becomes 2LW. The length is 5.5. Width is 3. So we have 2 times 5.5 times 3, which all of that is 33. So we have L plus 33, and we get that the total surface area, if we were to cover that with wrapping paper, is 289.7 square inches. Okay, so the next one. I know this maybe seems complicated because we have 2 equations, but just remember you're just plugging numbers in. Okay, so now we have a triangular prism. So you still start out with lateral area is capital PH, perimeter of the base. A triangular prism, the base is a triangle. So we have the perimeter of that triangle, so I've got 8 plus 15 plus 17 times the height of the whole figure. That is how we get our lateral area, which comes out to 800 meters squared. So then to find the total surface area of this figure, I take that previous answer I just found, 800, plus 2 times big B, area of the base. The area of this base is a triangle. Area of a triangle is 1/2 times the base of the triangle times the height of the triangle. Okay, not the whole figure, just of the triangle. So we have 2 times, so we have 1/2 times the base of the triangle times the height of the triangle. So when we do that, half of 8 is 4. 4 times 15 is 60, times 2 is 120. So then we add those together to get our final answer. So using that, I want you to try 1A and 1B. Pause the video, try those, and then I'll go over it with you. On 1A and 1B, we're finding the surface area. So on 1A, we have a rectangular prism. So first we find our lateral one, big P, H means the perimeter of the base. So technically you could use this as your base or this rectangle on bottom. On this one, it doesn't necessarily matter because they're the same. So to find the lateral, on bottom, I'll do it first. So I have 2 times 1.4 plus 2 times 1.3. And let's see. We get 5.4. Then we still have times the height of the whole figure. So since I did this, the height would be 1.2. So 6.48. So then to find the surface area, I have that answer plus 2 times big B. Big B means area of the base. I did this rectangle on bottom, this one, as my base. So I would do 1.3 times 1.4 to get big B. So 2 times 1.82. So we get 6.48 plus 3.64. So 10.12 would be my surface area on that. Let's see, I did meters times meters. So it's just meters squared. Okay, on 1B, that is a triangular prism. So the perimeter of the base is a triangle. So I have 5 plus 13. This one, it's just over there, which is 12. So 12 plus 13 plus 5 is 30. And then I still have times the height of the whole figure. So 15. So feet times feet. So that is 450 square feet. So then the actual surface area is L, what we just got, plus 2 times area of the base. The base is a triangle, so that is 1/2 base, okay, times height of the triangle. Oh, I did that, that's not 13, it's 5. So half of 12 is 6, 6 times 5 is 30, so 2 times 30. Let's see, feet squared. So 450 plus 60, 490 square feet is our surface area of the triangular prism. Okay, so now we're going to look at same type of problem, but now using something other than just a shape. So it says Lucia is covering a box with fabric. It's a rectangular prism, and it measures 10 inches wide, 14 inches long, and 5 inches high. Find the amount of fabric that she needs. Okay, so you can draw a picture if you want to. You don't have to. Okay, a rectangular prism, it tells us that it is 10 inches wide and 14 inches long. I'm going to do my best. This is not going to be pretty. Okay, so it is 14 inches long, 10 inches wide, and 5 inches tall. Okay, so to find the lateral area, we have the perimeter of the base times the height of the figure. So this side's 14, this side's 10, so this back side is also 14. And this other side over here is also 10. So 10 times 2, which is 20, 14 times 2, which is 28. add those together, then times the height of the whole figure, 5, to get 240. Then to find the actual surface area, we take that previous number we just found plus 2 big B. Big B means area of the base. Base is a rectangle, so length times width, 10 times 14, then times 2. So then add those numbers together and we get that she will need 520 cubic inches of fabric, or square inches. Okay, so that's a realistic problem. I've used fabric for stuff like to make a little dress for my daughter. You have to measure stuff out to know how much fabric you will need. So I'm going to have y'all try one kind of totally jumping type of problem, but try number 2. Let's see. I'm not going to make you do the last part when it says determine how much paint he needs if 1 quart covers 100 square feet. You can to look at the realistic problem, but I'm not going to make you go back and see if he has enough paint. I just want you to find the surface area of this skateboard ramp, and then I will go over it with you. Okay, on number 2, it says that Mark is painting a skateboard ramp shown. And then it says find the surface area. And just remember, in case you tried to finish the rest of the problem, I'm not worried about if he has enough paint, then you would just subtract from your amount. But we're just going to look at the surface area of this skateboard ramp. So the first thing we can find is our our L, and then find the surface area. Okay, so the perimeter of a triangular prism is a triangle. So I have 5, 2, this side is just right there, 5.4. So that's 10, 11, 12.4 feet. And then I still have times the height of the whole ramp, which is 4. And I'd laid my calculator down. There it is. So I have 12.4 times 4. 49.6. Okay, that is just the lateral piece. So to find the total surface area, I take that amount plus 2 times big B. So 2 times the area of the base. The base is a triangle. So area of a triangle is 1/2 base times height of the triangle. Okay, so we have 1/2 base of that triangle would be this piece, that back side, 2. And the height of the triangle, it's kind of, think about it, it's upside down. So the height of that would be 5.4. Let's see. Yes, that's correct. No, do I have that right? Now I'm getting confused. Okay, so if we were to take this is the base, and stand it up, this is actually the height, the 5. If there's confusion on that, I understand why that picture is confusing the way it's set up. Okay, so we have 1/2 of 2 is 1, 1 times 5 is 5. So the area of the triangle is 5. 5 times 2 is 10. So 49.6 plus 10, so it is 59.6 square feet is the surface area. That means that's the part that he's going to have to paint. Okay, just the whole outer area of the ramp. Okay, now we're going to look at surface area of a cylinder. So on this, if you notice, if we take a cylinder and cut it open and have the net of it, the circumference of a circle, or the distance around it, is 2 pi r. So when we open that up, cut it, and lay it out, it becomes a rectangle with the distance of the rectangle being 2 pi r. This is the height of your cylinder. So for area of a rectangle, we know is length times width. On here, we already know this distance is 2 pi r, and it's h tall. So that is your length and width. 2 pi r is your length. H is your width of this rectangle, since it is pieced together by 2 circles with radius r. Okay, so we are still going to use that same initial S equals L plus 2B, but just like with everything else, L and big B depend on what shapes you have. So let's look at that. For L, lateral area, which means perimeter of the base, circumference of the base, times the height. So for that, we just have L for a cylinder is 2 pi RH. Then for your surface area, you have L, what you just had, plus 2 times big B. Big B means area of the base. The base is a circle. Area of a circle is pi r squared. So if you want L equals 2 pi r, I'd write that down for a cylinder. Your surface area equals 2 pi r, h, that L, plus 2 pi r squared. That is surface area. It always starts with this, but they change according to what shape you have. So this will be the lateral area and surface area formula for a cylinder. So you might want to write that down. The reason it's 2 pi r squared is because there's 2 bases, just like before. Let's look at an example. All right. Find the lateral area and surface area of each cylinder. So I guess we're looking at this one over here. So for the lateral area, we know it's 2 pi rh. We just look. They gave us the radius, which is 6. Height is 12. So I have 2 pi, r is 6, height is 12. Now you're just multiplying. 2 times 6 is 12. 12 times 12 is 144 pi. So when they ask for lateral area, you could go ahead and plug that in your calculator and round. But for me, it's actually, or not for me, for this too, leave it as 144 pi to plug it into your other equation because it makes it a little easier to not have to have those decimals until the very end. So for surface area, we have L, which is what I just said, use that 144 pi, plus 2 pi r squared. R is 6, so I'll plug 6 in. 6 squared is 36 times 2. Leave it times pi. So let me see what that comes out to. 6 times 6 is 36 times 2 is 72 pi. The reason I say that is right here you get 144 pi plus 72 pi. Since they are both times pi, just as if they were both times x, I can add those two numbers now and keep it times pi. 144 plus 72 is 216 pi. Then multiply by pi at the very end, so we don't have to round until way over here. So it is approximately, they did squiggles because we had to round, 678.6 square meters. That is the surface area of that cylinder. Okay, on B, they just give us dimensions. They don't give us a picture. Diameter of 20 inches and a height of 5.6 inches. So we just plug it in, but we do have to pay attention. They give us diameter, and for both formulas, we just need radius. So if the diameter is 20, the radius would be half of that, which is 10. So 10 is what we will plug in for r. So I have 2 pi r, which is 10, and times h. And they told me the height is 5.6. So then you're just multiplying all of that. Leave it times pi so that you can plug it in over here for L, because the surface area is L plus 2 pi r squared. We just said r is 10, so we plug that in. 10 squared is 100, times 2 is 200. So right here is what I'm talking about. They finally wrote it out. 112 pi plus 200 pi. You can combine those. So that way when you're plugging it in your calculator, it's more accurate. So we would have 312 pi. Then plug that in the calculator and round to the nearest tenths place, and we get 980.2 square inches. So I want you to try number 1. Find the lateral area and surface area of a cylinder with a radius of 7 centimeters and a height of 12 centimeters. You'll round your answer to the nearest tenth. So I want you to try that, pause the video, and then I will go over it with you. On number 1, I can't remember now if it said find the lateral area or the surface area of a cylinder, so I'm going to find both just to make sure. But it says of a cylinder that has a radius of 7 centimeters and a height of 12 centimeters. So to find that lateral area, we have 2 pi rh. They told us radius was 7 and height was 12, so we just plug it straight into that. So 7, so we can go ahead and multiply all our numbers. Easy peasy. And you could go ahead and multiply by pi there if you want. I'm just going to go ahead and show you the next numbers. Oh gosh, I forget where pi is on my graphing calculator. Oh, there it is. And round, so 527 point, I'll round to the tenths place, 0.8. And this is centimeters, okay? If they had said surface area, because I can't remember what they said, lateral area or surface area, I thought it was just lateral area, but gonna go ahead and continue just in case. Surface area is gonna be that amount plus 2 pi r was 7. 7 squared is 49. 49 times 2, 98. Plus 835.7 is our surface area. So whichever one it said, find, I can't remember looking back at it. There's lateral area, this is surface area. Okay, we'll look at a problem now where we're comparing two cylinders. So it says Isabel is making 2 cylindrical candles, each with a radius of 1.5 inches. So they have the same radius. One candle is 4 inches tall and the other is 8 inches tall. Is the surface area of the larger candle twice that of the smaller candle? So we're going to have to find our surface areas and see if the bigger candle is twice the amount as the smaller candle. So we find them separately. So they said, okay, candle A, that'll be your smaller candle. Candle B will be our bigger candle. So we already know it's S equals L plus 2B. Since it's a cylinder, L is 2 pi RH, 2 pi r squared. So from this point, we're just plugging in numbers. So the radius on both of them is the same, 1.5. The height of the smaller candle is 4. The height of the larger candle is 8. So looking at our 2 pi RH, I would multiply this. When I do that part, I get 12 pi. 2 pi r squared, 1.5 squared, times 2 is 4.5 pi. So when we add those together, we get 16.5 pi. So let's do the other one and see. So then we plug in same radius, but this one has a height of 8. So we're multiplying these numbers to get 24 pi. So if you notice the lateral areas, 12 pi, 24 pi. As far as the lateral area, it's twice as much, but it said the surface area. So when they plugged this other in, they got 4.5 pi to get a total of 28.5. So to see if it's twice as much, 16.5 times 2 comes out to 16 times 2 is 32. 0.5 times 2 is 1, so 33. So it's just shy of being twice as big. It's not quite. So you would just say, no, it's not twice the surface area. Okay, so I want you to try number 2. It says which has a greater surface area. So this one you're finding both surface areas and just seeing which one is bigger. A tuna fish can with a diameter of 8 centimeters and a height of 4 centimeters, or a soup can with a diameter of 4 centimeters and a height of 8 centimeters. So they kind of just swapped spots. So go ahead and calculate both of those and then see which one has a greater surface area. And then I will go over it with you, and this will be the last problem we look at today. Okay, the number 2 said, which one has a greater surface area? A can of tuna that has a diameter of 8 centimeters and a height of 4 centimeters, or a soup can with a diameter of 4 centimeters and a height of 8 centimeters. Excuse me. So first thing we find is our lateral area, 2 pi RH. So for this one, I'll do it in green. We have 2 pi, okay, the diameter is 8, so don't forget you have to find the radius. If the diameter is 8, the radius is half of that, which is 4. The height is 4. 4 times 4 is 16, times 2 is 32, so then I have 32 pi. Actually, I may leave it 32 pi for now. Okay, surface area is going to be 32 pi. Plus 2 times big B, which is area of the base. It's a circle, so pi r squared. So pi radius, we said, was 4 squared. 4 times 4 is 16, times 2 is 32. So 32 pi plus 32 pi. That's why I waited till the end, 64 pi. And then I will round 201.1, and that was centimeters. So this one has a surface area of 201.1. So now let's find out for our soup can. So we have 2 pi RH. The diameter is 4, so the radius would be half of that, which is 2 times the height. 8 times 2 is 16. 16 times 2 is 32. So 32 pi. Okay, then my surface area, we have 32 pi plus, now I have 2 pi r squared. R was 2. 2 squared is 4. 4 times 2 is 8. So 32 pi plus 8 pi comes out to 40 pi, which is 125.7 surface area. So the one that had a greater surface area would be the can of tuna. Tuna.